Okay, we're going to look at a second question here, and it is on the line again, and it is 2015 paper 2 question 2. So we start out and we say that the line P makes equal intercepts with the axes being the x and y axis at the points A and B. Now, equal intercepts means that the distance from here to here, we're going to call it, let's say, 1 unit, okay, is equal to the distance from here to here. 1 unit. We're just calling it 1 unit. We don't know what it is, but we're calling it. We're going to write down the slope of this line P. Now, slope, there's two ways of getting the slope. The first one is with the formula y2 minus y1 over x2 minus x1, but we don't have any information on the points here, so we're going to use rise over run. And if we say, let's say, for instance, that this is 1 unit and this one is 1 unit, you just say 1 over 1, and that's simply equal to a slope of 1. Second thing is the point 1, 5 is on the line P. Now 1, 5 would be somewhere up here. I'm just guessing, okay? 1, 5, let's say, for instance, okay? And write down your answer in the form. We have to find the equation of P. So we have this line here. We now know the slope of this line, and we also know a point on the line. So we want to find the equation, and we have to find the equation in the form ax plus by plus c, which just means that everything is on the left-hand side, all letters and numbers, and then on the right you just have a 0. So we begin and we say we want the equation. Go to your table book and you'll see that the equation of line is given by y minus y1 is equal to m times x minus x1. And to use this, all we need is a slope m and a point x1, y1. In this case, x1, y1 is 1, 5. So we're going to put those values in. Y minus y1 is a 5 is equal to m we found to be 1, x minus 1. Y minus 5 is equal to 1 times x is x, 1 times minus 1 plus and minus gives you a minus 1. We're going to move everything over to the left hand side. You get minus x plus y minus 5 plus 1 equals 0. Minus x plus y minus 4 equals 0. And again, we're not normally giving up a minus x in our answer. So what we'll do is we'll change the sign of everything. It's just convention. That's what you normally do. X minus y plus 4 equals 0. And that's our answer. Okay, then they say the line Q, so this one here, is perpendicular to P. And it also contains the point 0, 0. So in other words, you see Q, and this is here the point 0, 0. And then we have to find the equation of Q. So again, remember, to find the equation, we need two things. We need a slope and we need a point. Now, we don't yet have the slope of Q, but we say a point, one of the points is given as 0, 0. That's in the question in part B. So we got to figure out what's the slope of Q. Now, we know the slope of P is 1, and we know that Q is perpendicular to that. So what can I say about perpendicular slopes? Perpendicular slopes, we got to say, okay, if one line, and we'd say P has a slope equal to 1, and we're going to change that, we're going to say equal to 1 over 1. Then Q, a perpendicular line, has a slope of, now we've got to change the sign, that's the rule, to find a perpendicular slope, change the sign. This is a plus, you change it to a minus, and you flip the fraction upside down, and you get 1 over 1, which is equal to just minus 1. And that's the slope then for this perpendicular line Q. So we have a slope, minus 1, 0.00, and we get the equation. Equation of the line Q is y minus y1 equals m times x minus x1. Y minus, all right, so our point here is 0, 0. We're going to call this x1, y1 for putting it into the equation. Y1 is 0, minus 1 is a slope, x minus 0. And then you get y, ignore the 0, minus 1 times x is minus x, and minus 1 times minus 0 is 0. So, and then just to where we want everything over to the left hand side, that implies our line is x, we're taking the x over to the other side, it becomes a plus y, and there's nothing left on the right hand side, so you just put in your 0. And that's the answer there. Okay, part C. The lines P and Q intersect at the point C. Explain why the triangle OCA and OCB are congruent. Okay, so what I'll do here is I'll just take this down. Alright, so we get rid of all that stuff. No, we can't. Anyway, alright. What we say to get congruent, okay, we're going to show, so we're talking about this one here. That's triangle OCA, and OBC is this one here. So we've got to show that they're congruent. Now, first thing you can do to show congruent means they're the sides are the same length and the angles are the same size. So what we can say is, first of all, we know this line here is the same as this line here. That was given to us at the start. So what we're going to say is the length of OA is equal to the length of OB. Next thing we can say is OC is a line that's common to both triangles. So we're going to say OC is the same in both OC. And then we know this angle here is the same as this angle here. They're both right angles because these two lines are perpendicular. So we're going to say BCO is the same as ACO. So we have proven side is the same, another side is the same, and then an angle is the same, which is enough to prove congruent. That implies triangles are congruent. And we say side, angle, side. Okay, thank you.